Hi, welcome. Today's lesson is going to be about accuracy, precision, and error, okay? First two things I'm going to talk about, though, are accuracy and precision, okay, and the difference between those two things. Now, you probably have heard these words before, but let's just talk about them really quickly. So accuracy is going to be the value of how close a measurement is to the actual or true value for that thing. Meaning, if you were to weigh something on the scale and then look that thing up in a book of what it should be, accuracy would be the number on the scale is really close to what it is in the book, okay? And I always remember accuracy means, or accuracy starts with A, and actual starts with A. So accuracy deals with how close are we to the value that we want or what it actually is, okay? Now precision is going to be how close the measurements are to each other, okay? So we're talking about how close something is. So say, for instance, you measure something 3 times, okay? And let's say that those measurements are all really close to each other. That would mean your 3 measurements are very precise, okay? So I like to think about accuracy and precision as, say you're playing darts or doing archery, of hitting a target. Okay, so let's talk about whether something is precise but not accurate. What do you think that would look like? Okay, if something is precise and not accurate, so obviously we actually want to hit the center of the target. Okay, that would be accuracy. However, this target is not going to have accuracy. Okay, however, each dart is going to be really close to each other to indicate that that is precise. Okay, so that would be like me saying, okay, I hit my first dart here, not accurate. I hit my second dart here, still not accurate because it's not hitting the bullseye, and third dart here, okay? So neither of my darts are accurate because they're not hitting the center, but they're very precise because each dart is really close to each other, okay? So that would be precise but not accurate. What about if I had something that was accurate and precise? Okay, so now obviously we would think that each dart is going to be really close to each other, but if we're talking about something that is accurate as well, where do you think those darts are going to be? They're going to be really close to each other on the bullseye, okay? So that would be like me hitting 3 darts really close to each other, right in the middle where they should be, accurate and precise. Okay, what does accurate but not precise mean? Well, this one's a little bit more difficult to understand, so just follow me here for a second, okay? Accurate but not precise. Obviously, since it's not precise, the 3 darts cannot be close to each other, okay? But they need to average the bullseye, meaning if I was to take all 3 of them, their distance from the bullseye, and average them, it would give me an accurate value, okay? So let's look at what that looks like. That would be like me hitting a dart here, a dart here, and a dart here. They're not precise because they're not touching each other or close to each other, but if I was to take the average of those 3 darts, they would hit the center of the bullseye. So these darts are accurate, but they're not next to each other, therefore they are not precise. Okay, that one's a little bit more difficult to understand, so if you have questions about that during class, please let me know. Okay, then what do you think the 4th one is? It's going to be neither, okay? So this is going to be neither accurate or precise, okay? So that means none of the darts are hitting the center, and none of them are close to each other. So you got a free-for-all here. You got a dart here, I got a dart here, and I got a dart all the way out here. Those darts won't average the center, nor are they close to each other, so they're not accurate or precise. Okay, so that is just simply accuracy and precision when we're talking about measurements. Okay, most of the time we'll talk about accuracy and precision within the lab setting. Okay, second thing that I'm going to talk about today is determining error. Okay, so let's say that you're supposed to get one value in the lab and you get another one. You're going to have an error for what actually happened during the course of that lab. Okay, all right, so error is actually defined by the difference between the measure value and the actual value. So we're not talking about a measurement that has accuracy. We're talking about something that is not the actual value, okay? So to calculate error, so here's an equation. To calculate error, error is going to be equal to experimental, so what you get in the lab, minus the actual. So what was it actually supposed to be, okay? This value can either be positive or negative, right? Because if this number is smaller than that number, you'll get a negative number, okay? So let's find the error. So this is an example here. Let's find the error if a desk is 23 centimeters, but you measure it to be 21 centimeters, okay? So let's write our equation. So error is going to be equal to experimental, so I'm going to shorten that there, minus actual, okay? So experimentally, I found the desk to be 21. Why? Because I measured it myself. So this is my experimental, so equal to 21 centimeters, minus, this is what the desk should be, so that's actual. So it's going to be minus 23 centimeters. So what does that come out to be? 21 minus 23 is going to be negative 2 centimeters. So that is my error for this desk. Okay? Questions about that? Make sure you write them down if you do. Okay? Error is nice to know, but typically we use this thing called percent error. So like if I have error within the lab, I should be able to calculate the percentage of how much error I actually had, okay? And that actually means more to me in a chemistry type setting, okay? So let's look at this. Percent error, which is actually more important than error, is going to be the absolute value. Absolute value obviously means that if you have a negative number, it's going to make it positive, okay? So percent error is the absolute value of the error, so experimental minus actual, divided by the actual value, okay? So what it should be. So let me make that clear. Actual is what it should be, like it's defined. And then since we're talking about a percentage, we're obviously going to have to multiply that by 100. Okay, so here's the equation. Percent error is equal to error divided by the accepted value times 100. Okay, so I'm going to rewrite that with our error equation. Okay, so I'm going to say percent error is equal to experimental minus actual, and we're going to take the absolute value of that, so we're not going to have any negative numbers because you can't have a negative percentage here, divided by actual, and then we're going to multiply that by 100 to get a percentage. Okay, so again, this can only be positive. Why? Because I'm taking the absolute value of the error, so I'm going to find the error from the problem above. Now remember, our error from the problem above was negative 2 centimeters, okay? So percent error is equal to, and if you remember, I had 23 centimeters minus, oh, I'm sorry, I have it backwards here. 21 centimeters minus 23 centimeters divided by, what should it actually be? It should actually be 23, so I'm going to do 23 centimeters. And you'll notice that the centimeters will cancel because we need a percentage. And then I'm going to do times 100. So that's going to be equal to negative 2 centimeters divided by 23 centimeters. Okay, well it's not negative anymore, I'm sorry. The actual value makes a positive. So centimeters cancels, and I'm going to do that times 100. Okay, so let's plug that into our calculator and see what we get. Alright, so let's see here. So I'm going to have 2 divided by 2 divided by 23 times 100. So my measurement on this desk is going to have a percent error of 4.35%. So I'm going to write that here, 4.35%. So what does that value mean? That value actually means that me measuring that desk, I had a 4.35% error. Now, where could that error come from? Well, it could come from a multiple multiple things. It could come from your ruler is inaccurate. You measured the desk inaccurate, meaning you missed some inches or centimeters somewhere, or you over measured. Okay, so those are all things that could have had error present. So thanks for listening.